Alright, good morning. Today we're going to do a new chapter. It's a simple chapter, correlation and regression. From this chapter I will give you the assignment. Actually. Okay, correlation and regression. Let's say you have two variable. One is advertising. In this case, it's advertising, and another one is sales. Okay. So you have two variables. If we want to, let's say you have a table there. Advertising and sale. So when you plot, let's say advertising is your x axis and s is your y axis. When you plot the data here, you will get something like this. Okay, this is called a scatter diagram. If you see all the points there, you can see in this case you can see a pattern here. Okay, all the points going like upwards. Okay, all the points are going upwards. Some almost in the one they fall in one straight line. Okay, this kind of diagram called a scatter diagram. And from the scatter diagram we can see how strong is the relationship between advertising and sale. Okay, if they fall exactly in a straight line, either it's going up or going down, something like this, then the advertising and sales have a strong relationship, and we will claim that they have a strong correlation. Okay, so let us go to the next slide. So what is correlation? Is a statistical relationship involving dependency. Okay, how strong, how dependent is the one variable to another variable. Okay, so to measure the strengthness of the dependency. Okay, if you have one variable here x and y, how strong this x influence the y. Okay, the y we call it as independent variable, and y is dependent variable, x is independent variable. Okay, so the y depends on the x. Just now we saw here advertising influence sale. The more you advertise, the more your sale goes. Okay, you have to understand which one influence which one. Normally the first column is x, the second column is y anyway. So to see the relationship, how strong is the relationship, we can measure the relationship quantitatively, and the name for that measurement here we call it as Pearson coefficient of correlation, and we denote it by R here. Okay, the measurement of degree of scatter between the data values. How strong is the relationship between the two variable? We can do some computation and we can come out with a number, and that number is always in between -1 and 1. Okay, 1 means 1 and -1 is strongly correlated. Both of the variable are very strongly correlated, dependence. Okay, and the less scatter the data, the stronger the relationship. And in between, less scatter means, as I told you, okay, we will see the example now. You see this diagram, you can see that there is some variable here x, some variable here y, and you can see all the plottings falls in a perfect straight line. A perfect straight line is going up the hill is positive, coming down the hill is negative. Think like that. Okay, hopefully you guys know, most probably you have learned this in mathematics. Going the gradient of a line going up the hill is positive, coming down the hill is negative. Okay. Now if you see this scattered diagram, the plotting falls in a straight line, perfectly in a straight line going up the hill, then for sure the R is 1. Later we will see how to compute this. There's a formula for this. Now look at this one. It is going up the hill, but then all the points are a little bit scattered. It's not falling in the straight line. So when we compute the R, it might not be 1, it may be around 0.8, something like that. It's still positive because going up the hill, isn't it? Still positive. Now like this, it's not going up, not going down, even though it's a straight line, it's a horizontal line, it's not going up, going down. This is 0, no relation at all. And this one, still horizontal line, but not in a perfect thing. Okay, still horizontal line, and all the points are not perfectly fall in the straight line, but we call it a little correlation. And this one coming down, you can see the line going down the hill is a negative correlation. Negative correlation may be around 0.8 because all the points are not falling perfectly in a straight line. Okay, hope you guys understand. Negative doesn't mean it is a weak correlation. Doesn't mean it weak. It's negative also can be strong. So what is the explanation for each and every number we get? We can go here now. You can use this one. Okay, hopefully everybody has the slide I have shared with you earlier. If R equal to 1, okay, we will compute that later. If R equal to 1, then you can use these phrases. Perfect positive correlations exist between the two variables. As x increases, y increases. So just now, the first example, we saw that x is the advertisement. As advertisement increases, the sale increases. Something like that you can write. Later I will show you the tutorial. I have given the full answer for you. You can refer to that. R also can be in between 0.8 and 1. Then you can write strong positive correlation. As long as there is a positive correlation, is x increases, y increases. Okay, R can be in between 0.4 and 0.8 is a moderate positive correlation. X increases, y increases. If x is between negative 0.4 and 0.4, very little correlation. No need to write x is increase or decrease because it is scattered up and down. There's no what you call a good observation on this relation. If R is in between negative 0.4 and negative 0.8, then it's a moderate negative correlation, almost the other way around. Here 0.4, 0.8 isn't it? Moderate positive correlation, and negative means negative correlation. And here x increases, y decreases. That is the difference. You have to understand that, take note on that. And if R is in between negative 0.8 and negative 1, then strong negative correlation, x increases, y decreases. And you can see that if R is equal to negative 1, it has perfect negative correlation. It's a perfect correlation. It's just the type is negative or positive. Okay, as x increases, y decreases. This how you, yes.
One of my friend is at the waiting room still.
What is that? Waiting list?
Waiting room. Someone is still at the waiting room. I'm sorry.
Okay. Okay, thank you. I didn't hear anything anyway. All right. Now, with all this explanation, scatter diagram, so far what we did, we are looking at correlation now. Two variable, you plot, you get a scatter diagram. From scatter diagram, what you can notice, whether the relationship between two variables are strongly related and not strongly related. Okay, like this. When you plot a scatter diagram, you will get like this, and from here you can see that the data is falling in a line or up and down or horizontal, something like that. This is, you can only observe and explain subjectively, okay, all these things, scatter diagram. But is there any method to measure the dependency, the correlation, the relationship between the two variables? Is there any method? Answer is yes. That's where Pearson coefficient of correlation comes into the picture. It is R, and the number is in between -1 and 1. Okay, now let us go to the formula for that. Calculating Pearson coefficient of correlation. Okay, first of all, you will compute R square. R square is known as coefficient of determination. Okay, explanation for all these things are inside the tutorial, how to explain each and everything. I have given full answer for all the questions, you can refer. So this is the formula. Actually, basically what you have to find, you have to find the summation of x, summation of y, summation of xy, summation of x square, summation of y square, and the n is the number of pair of data you have. Okay, this is coefficient of determination. Now for you to find the R coefficient, Pearson coefficient, you just square root. When you square root, remember here, when you square root, you will have plus minus, and the plus minus you have to put according to your scattered data. If your scattered data is like this, you put a plus. If your scattered data is, the pattern goes down, then you put a minus. Okay, now look at this example here, just have a read. Table shows advertising expenditure. Advertising expenditure and associated sales of the particular product. Find R and comment on the association between the two variables. Now here expenditure would be X, because this is where you have to determine. This would be your X and this would be your Y. Okay, don't get confused, because expenditure will determine your sale, not sale determine the expenditure. The more you expend for your advertising, the more your sale. Okay, something like that. So if you go down the computation, this is going to be your X, this is going to be your Y, and you can compute the sum. We need this one. This is the summary of statistics. We want summation of y, summation of x, summation of x square. X square, you can see here, 8 times 8, 64. 12 times 12, 144. 11 times 11, 121, and so on. You get this one. Same goes for the y. 25 times 25, you get this one. So summation of y square and summation of xy. With all this summary of statistics, okay, all the summation, and of course n is 10, number of pair. 1, 2, 3, 4, 5, 6. My network connection is not stable today, so my writing is not very smooth. One, two, three, 4, 5, 6, 7, 8, 9, 10. Okay, 10 pairs of data. With all this data here, number here, we put inside the formula. Okay, basically I have already square root the r square. Just now the formula was what is that? This one, isn't it? So when you square root, okay, this cancel each other, isn't it? Cancel each other. So left is this one. So you can consider this one only. This is your r. Okay. So if you put inside the formula and you compute, you will get r 0.9482. Of course, if you plot this, your scattered data will go up. Okay, your scattered data will go up. That's why I put a positive here, otherwise I will put a negative. I leave it to you as an exercise. You can try later. Later I will go through the tutorial and explain to you a little bit on that. Explanation: the correlation coefficient is 0.9482, is in between 0.8 and 1. Strong positive correlation exists between the two variables. As expenditure increases, sales increases. This is how we have to explain. More explanation we can see in the tutorial answer later on. Now I give you some time. Okay, I want you to compute this the what you call the r for this data. I give you some time. Try first. Take this data, use that formula. You try. For your information, the scattered diagram, if you plot this, it's also going up the hill. So you can put a positive. But before that, compute the x, summation of x, summation of y, summation of all these things. Alright. I suppose everybody has the slide, so please refer to your slide, and I have given the full slide. The formula is there. I have also given one example there. Follow the example and try to get me the r here. Try. I give you some time. Alright, so most of you might be finished finding all this summary. Just double check here. Summation of x should be this one. Summation of y x square 436,205 y square 211,8025 xy 955,0660 and n is 12. Hope you get all this correct. Okay, this would be the summary statistics for all this summation here. Using this data here, if you compute your R should be 0.96 in 2 decimal places. Okay. Double check. Hope you get this answer. Okay. Hope you guys did this by using this formula here, right? Now once we have finished this, okay, this is the whatever we did here now is a measurement to show how strong is the relationship between these two data. So here is quite strong. 0.96 means is actually quite strong, and you can use this same explanation here because it's in between 0.8 and 1. So you can write that a strong positive correlation exists between the two variable as what is this, as the temperature. Here temperature is x, this one is y, because temperature influence the ice cream sale. Okay, the higher the temperature, the higher the ice cream sales goes. That's how it goes. Okay, when the day become hotter, people want to eat more ice cream. It's natural, right? Okay, so in this case you can see as the temperature increases, the sales increases, something like that. Now, as I told you before, when we plot a scatter diagram, we notice that it might fall in a straight line. Am I right? So you can see there's one straight line whereby it can represent all this, the scattered plot here. It may approximately represent all this scattered plot here. So our next job is to find the name for this line. Okay, straight line, remember what is the standard form of straight line? Y equal to mx plus c. Recall back your mathematics, whereby m is your gradient and c is your y-intercept. Okay, so we are going to find the straight line which represent the data. It can be going up or going down. Okay, now to find the straight line, we have to go for the next section known as regression. Okay, known as regression. Regression is as I told you, we have to find a regression line, best fitted line, and the formula is this one. Y here it is written y equals to a plus bx. Okay, this is a resemblance almost similar to our y equal to mx plus b. Normally we use this one, mx plus c, sorry. So our gradient is here, the coefficient of x, the number in front of x. So here this would be the gradient now, and this would be your y-intercept. Okay, so basically you need to find a and b. For you to find the a and b, uh, this one all you can go through by yourself later. So for you to find A and B, the formula is given here. Okay, once you find B, using B you can find A, and then you substitute inside here, that's all. Alright. So for example, just now the sales and expenditure, the one we did just now, sales and expenditure, we have this one, isn't it? So we substitute inside here. Our B will be 2.14 and our A will be 8.13. The regression line is this. Now I want you to do this for this. You have computed these statistics, isn't it? Okay, using this, find me the regression line for this exercise in class 1. Find me the regression line for this one. Find me what is your A and B, let me know. So by using all this data here and using this formula here, if you compute the B your B will be 30.09 and A will be somewhere here. Okay, this would be your answer for your B and A. So the equation would be like this: y equal to negative 15947 plus 30.09 x. That would be your equation. There's the last exercise here also. In the last exercise, let me give the answer, you may try at home. Summation of x would be 507. You can copy this first. And your linear regression line, your wait, let me give you the R first. The R is 0.92. If you plot, the scatter diagram goes up positive. You must try this, you try at home, practice this. And your linear equation is 0.49 plus 0.27x. Okay, this would be your A, would be your B. Copy this, you try at home. So your assignment going to be based on this correlation regression. Later I will send you the assignment question. So two things I need to decide: your assignment due date and also your test due date. I suppose all of you are doing the tutorial until chapter 3. Maybe you are still doing, checking the full answer. So hopefully no doubt. If you have doubt, you can ask me now, or you can ask me later in the WhatsApp. You can WhatsApp me. Okay, you can WhatsApp me asking any doubt related to that. Take your time and do. Still, I yet to decide the test question. Not immediately. So if you see, okay, hopefully you guys copied this, or later you can see the video again. Look at the tutorial here. Okay, each and every question, there is, how many questions are there? I have given 10 questions. Okay, just for your practice purpose, it depends, the data depends on the thing. Now look at, maybe for example, look at question 5 here. 10 salespeople were surveyed, the average number of client contact per month and the sales volume were recorded for each data is given. Okay, number of clients contacts, sales volume. So as the number of client contacts is influencing the sales volume. The more people you see, the more you sales. Okay, that's how it goes. So this would be the number of clients contact is X, sale volume is Y. And A to F, I have asked the same question to each and every data here, A to F. Okay, so use the given data to create a scatter plot. Find the estimate regression line using a least square method. This is actually the regression line, the one we did A and B just now. Interpret your result. You can see the question, the answer anyway. Full answer is that. Okay, I no need to give the full answer anymore. The full answer is given in the answer, the last part. Estimate the sales volume when the number of clients X, I mean this 60. Here you will get some regression line, isn't it? A plus BX. When they ask you to estimate the sales volume when the number of clients 60, first of all, number of clients is X. You have to determine that. Replace the 60 inside the X once you find the A and B. Whatever value Y you get, that is the sales volume. Okay, that's how we go. Find the coefficient correlation and interpret the result. Look at the answer, how I interpret. Find the coefficient of determination, interpret the result. The interpretation is almost the same for each and every question. Now look at the answer now. So this is the scattered plot. Okay, the full answer is there. Okay, of course, before you see the answer, you try to plot first, see whether you get this or not, and you can see the thing going up. It's a positive, and I have given you the A and B here. Okay, every time the number of clients contact rises, okay, by 1%, the sale volume increase by increase. This is how you explain the regression line. This one is 1. If you put 1 here, how much? You look at this number only. Plus 2.3 means is increased by 2.3 thousand units, something like that. And of course, just now we have to put 60, isn't it? So if you put 60, you will get this one. This would be your R, and this is the explanation. This is the R square. This is the explanation. The explanation is same with all the questions. So I want you to try first. Try these questions, only 10 questions for correlation, regression. Any problem later you can ask me. Okay. I suppose that's all for today. If you have any question, you guys have any question related? Okay, before that, as I promised, I told you I will spend some time for the tutorial, the one, the first 3 chapters. For today, I have finished this chapter, correlation, regression. That's all. Correlation, we have to find the R. Regression, we have to find the line. Okay. This chapter is finished. Next class on Sunday, we are going for the new chapter. Okay, I will share with you what is the chapter. Okay, before I end up, is there any question related to chapter 1, chapter 2, chapter 3 on the tutorial, or you guys are still doing it? You guys need some time. You can always ask me in the WhatsApp once you check everything, of course before the test. Okay. Any question related to the, if you have, you can ask. Otherwise we will stop the class.
Doctor? Okay.
Wait, somebody, Shakira, are you Shakira?
Yes, me.
Okay, for the wait, let me read the thing. For the scatter diagram, we need to draw in paper graph or just sketch. Just sketch is enough.
So means sketch in
Yeah.
A4 paper lah.
A4 paper, yeah.
Okay, okay.
Just
Right,
sketching
that's
is
okay.
just enough. Just to see whether the pattern goes up or goes down. That's all. Don't need to use graph paper anyway. Don't need use.
Okay, okay.
All right.
Thank you, Doctor.
Okay. Anyway, guys, we will stop here. Any question you can ask me. Don't worry. It's not that you have to ask me in the class or tutorial. You can always ask me in the WhatsApp. I'll try to answer as fast as possible. All these things. You still have time to practice. You practice yourself. I'll give you some time. And your assignment also, I'll give you ample of time to do that. The due date won't be that fast. Okay. With that, I would like to end up the class for today, and I'll see you all on Sunday. Okay. So please do all the tutorial question, and as I give you all the full answer, you can always check and prepare yourself for the test and assignment. All these things. With that, thank you and take care. Bye bye. I see you guys on Sunday then.
Thank you,
Thank you,
Doctor.
Doctor.